Today we will discuss about the product of vectors. Okay. So basically product of vectors may be of two types. Now the first one is dot product. It is also known as the scalar product. And the second one is known as cross product. It is also known as the vector product. Okay, it is not the usual multiplication 2 multiplied by 3, you add 2 3 times. It's not like that. Product of vectors is the way it is defined to be. So first we will discuss dot products. Scalar product means the outcome of dot product is a scalar, and cross product is vector product means the outcome of the cross product of two vectors is a vector. Okay, so let's discuss first dot product. So I'll discuss it in the easiest possible way to apply, so that you can apply dot product to solve problems. I am not going into huge depth of it right now. Okay, so dot product is defined in this way. Two vectors a dot b is defined as ab cos theta. Okay, now suppose then theta is the angle between the vectors a and b, angle between vectors a and b, right? Okay, so suppose these are two vectors a and b, angle between the vectors is theta, so a dot b is equal to ab cos theta. Now what is the physical significance of this a dot b? See, you can write ab cos theta as a multiplied by b cos theta. If you write a multiplied by b cos theta, what does that mean actually? See, b cos theta is nothing but the component of b in the direction of a, that's b cos theta. Okay, so this b cos theta is component of b along a. See, the component could have been negative also if this theta would have been obtuse angle, and this is the direction of a. If b would have been like this, say here, suppose this is a and this is b, then in this case the component of b on a, I mean in the direction of a, will have a negative value. Suppose this happens to be 3 and this happens to be 5, so here dot product would be how much? Here in this case, suppose this component in the direction of a happens to be here 3 and this is 5, so this the dot product would be minus 15. But if in this case, say a, it happens to be 5 and b is there and this component happens to be 3, then the dot product is plus 15. So this is minus 15, this value would be plus 15. However, okay, so it's component of b on a. Okay, also you can write ab cos theta as a cos theta multiplied by b. So a cos theta multiplied by b, what does that mean? This was a and b. So a cos theta is this, a cos theta is what? Component of a, component of a along b. So this is what it is, right? Okay, so the dot product, see, a dot b will be same as b dot a, so it follows commutative law, and it can be proved also that it follows distributive law as well. So A dot B plus C will be A dot B plus A dot C. This you can verify. Okay. Now, so for the unit coordinate vectors, what is I dot see I cap dot I cap? So it's magnitude of I cap. See, mod of I cap multiplied by once again mod of I cap into cos of 0. So that's 1, this is 1. So this happens to be 1. And same way j dot j happens to be 1 and k dot k also happens to be 1. While see I dot j, I mean I cap dot j cap will be 0 because the angle between I cap and j cap is 90 degree. So is j dot k and so is k dot I. All are 0. So following distributive law, if you expand, suppose I write here a1. Generally I write here this ax. So you can write that also ax I cap plus ay j cap plus az k cap. Right. Now say b vector is bx I cap plus by j cap plus bz k cap. So what will be a dot b? So if you follow distributive law, there will be 9 terms. See, 3 terms and 3 terms will make 9 terms. Some of the terms I will show here. Ax bx I dot I plus again multiplying this ay bx j dot I, again multiplying this plus az bx k dot I plus, and again these all terms. So ultimately you will have 3 terms. See, this part is 1, these all are 0. So ax bx plus ay by plus az bz, that is a dot b. And so you can express in terms of the components, express dot products in terms of components like this. Okay. And another use of dot product is to find angle between the two vectors using dot product. Finding angles between two vectors. Okay, so suppose you have two vectors in the xy plane. Suppose to find angle between say I plus j and say 3i plus 4j. Suppose we are solving this problem. So I plus j means which vector? So it's in the xy plane, there is no z component. So I plus j means here you have I, here you have j. So that is a vector I plus j. It makes an angle 45 degree. Okay. And another vector 3i plus 4j. See, that's 3i 3 times I here. So 3 times I plus 4 times j, like this. Okay, so this is 3, this is 4. So this angle should be 53 degree. Okay, so the angle between the two vectors, see, as you know, tan of 53 equal to 4 by 3. See, this is 3i, this is 4j. This makes this vector is 3i plus 4j. So so the theta angle between two vectors is 53 minus 45, that's 8 degree. Okay, now it is you can calculate just by drawing. here. But if you have a vector in 3 dimensions, say you have a vector in 3 dimensions, then how will you calculate this? You have to do a hell of a lot of job to calculate that, finding an angle between two vectors in 3 dimensional space. Suppose this is the xy plane and z axis on the top, you have these two vectors like this in space. So how will you move in space to calculate this angle? You have to move with a protector and calculate this angle. That is a difficult job. So we will learn a way by dot product. So by dot product, say to find angle between vectors, say this a1, just for a change, a1, this ax, ay and az, I am writing a1, a2 and a3, doesn't matter. Many people write like this also, and b1 I cap, b2 j cap plus b3 k cap. So you have to find this angle between the two vectors. Here I will use the definition of dot product. A dot b equal to ab cos theta. So therefore cos theta is equal to a dot b divided by ab. So a dot b, you know how to expand. A1 b1, this x component multiplied by x component, plus a2 b2 with signs, remember that, with proper signs, plus a3 b3 divided by a1 square, a2 square, a3 square, b1 square, b2 square, b3 square. This is how you can find the angle between two vectors. If the angle between two vectors is obtuse angle, then their dot product is negative. If it is 90 degree, the dot product is 0. See the vector, suppose you have a vector a and you dot product a with a, then what do you get? A into cos of 0, that's a square. So this a plus b, suppose this a plus b dot of a plus b, a plus b dot of a plus b, see it's if a plus b is equal to r, it should be r square, right? So let's expand. So a dot a plus a dot b or b dot a, whatever, plus again b dot a plus b dot b. So you have a square plus b square from here plus 2ab cos theta. Okay, so this is the magnitude, the square of magnitude of these two vectors. Okay. Now we'll solve one problem using dot product. It can be solved without dot product also, but as we have learned the dot product, we would like to apply. Say problem is like that: a and b are vectors such that a plus b is perpendicular to a minus b. Prove that a is perpendicular to b. So that is the question. We have to prove this. A and b are two vectors such that a plus b is perpendicular to a minus b. Prove that a is perpendicular to b. Okay. So, or sorry, problem is not like that. A is equal to b. So prove that, prove that a is equal to b. I mean their magnitudes are equal. Sorry. My God. Okay, so let's go ahead. See, a plus b is perpendicular to a minus b. We have to prove that a equal to b, that is that mod of a equal to mod of b. Now I will use here concept of dot product. For perpendicular vectors, their dot product is 0. So a plus b dot a minus b is equal to 0. Now I will use distributive law. A dot a plus b dot a minus a dot b minus b dot b is equal to 0. See, a dot b and b dot a are same, so we'll cancel this term. This is a square minus b square equal to 0. So a is equal to b. Their magnitudes are equal. Okay. Another an application of a dot product is calculating work done. So you have already known about position vector. So we'll combine that also, use that also in this problem. So okay, basically you know the work done by a force. What is that? Work done by a force is product of force and displacement of point of application of force in the direction of force. Point of application of force along direction of the force. So suppose a point you are applying a force F here, and due to that displacement is this way, S. Displacement is a vector. Now what's written? Product of force and displacement of point of application of force along the direction of force. That means if this angle is theta, you have to find this component of displacement in the direction of force. That's S cos theta. So work done is equal to F S cos theta, that is F dot S. This is the work done by a constant force. F is constant during this displacement, I mean journey of the point from here to here. The force doesn't vary, right? So F dot S. Okay, now you know that displacement vector is the, say this is the 1.1 and 0.2. So 0.1 the initial position of the point where the force is applied, and 2 is final position of the point. So to with respect to a certain coordinate system, we can describe positions by position vectors. See, that's r1 position vector, r2, right? So this S is equal to, we all know that it is change in the position vectors, r2 minus r1. So work done is equal to F dot r2 minus r1. So suppose just one more problem, say so due to a constant force, 3I cap minus 4j cap plus k cap Newton, a point is displaced from 101 to 54,6, all in meters. Find work done by the force. Okay, so you have to find the displacement vector. So the initial position vector r1 and the final position vector, that you have to know, r2 in terms of coordinates. So it's 1 I cap plus 0 j cap plus 1 k cap, and this is 5 I cap plus 4 j cap plus 6 k cap. Okay, so displacement S, displacement is equal to R2 minus R1. So you can subtract the I, j, k components separately. That's 4 times I cap plus 4 times j cap plus 5 times k cap. Therefore work done is F dot S, so 3 I cap minus 4 j cap plus k cap dot 4 I cap plus 4 j cap plus 5 k cap, and you know how to expand the dot product. So this component 3 multiplied by this component 4 plus this component is minus 4 multiplied by this component 4 plus this component is 1, here it's 1, here it is 5. So this much Newton meter mane joule. So that's 12 minus 16 plus 5. So how much is that? 1 joule. So the work done in this case comes out to be 1 joule.